opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome to another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project. And joining me today is my lovely partner and co-host, Leah Shaper.
Hello.
Welcome to the show.
There were some weird tempo shifts in the opening music. Did you notice that?
Yeah, it happens if you have your mic on and audio goes over it. It tries to let your audio in. Which is why I try to be quiet till it's done.
Yeah.
With all the fake applause and stuff. Well, ladies and gentlemen, welcome to the show. We've got a banger. We're going to be talking about many topics to keep you interested in listening. We're going to start off with the concept of a tsunami bomb. We're going to get into the fact that Russia has one of these called Poseidon. And then we'll talk a little bit about global warming, the climate change hoax. And we'll talk about some facts about the only important greenhouse gas is water vapor. And we'll show you why that is. In the second half of the show, we may want to debunk some of Ben Davidson's ideas. Earlier in the week, he showed a paper that came out and claimed that it had something to do with his Earth tilt catastrophe hypothesis, when in fact, it's simply discussing the Milankovitch cycles. And we'll get into that, and we'll tell you what the paper actually says. And a final paper coming from Russia, which does an analysis of magnetic field data. It reveals that there is no cyclic catastrophe, that there is, in fact, it proves that the variation in the magnetic dipole is highly variable and there is no pattern. Pretty interesting. And that means that, well, we're screwed, first of all, because we're in one of these dips, and the paper alludes to the fact that when you're going down the hill, you're going to keep going down the hill until it stops.
Yeah. I mean, it indicates that the conditions are predictable for a reversal or an excursion, despite there not being a cyclical pattern.
But it has to be happening in order for you to say it's happening.
Right.
Yeah. So that means it's happening, folks. So let's drop the first bomb here on you all, and we'll share the screen. Let me know if you could see this.
I can.
The tsunami bomb. The tsunami bomb was an attempt during World War II to develop a tectonic weapon that could create destructive tsunamis. The project commenced after U.S. Navy officer E.A. Gibson noticed small waves generated by explosions used to clear coral reefs. The idea was developed by the United States and New Zealand military in a program called Project SEAL. The weapons concept was deemed feasible, but the weapons themselves were never fully developed or used. A related concept called the bouncing bomb, which is kind of cool because they have a graphic down here. So the bouncing bomb is a bomb that comes in at a very low angle and skips across the surface until it reaches its destination. It sinks down and using a depth charge explodes at the proper depth. This would be used to blow up a dam or something like that to cause catastrophic failure. But that pales in comparison to the tsunami bomb. Now, did you just read the wiki or did you read into anything else about this?
I just read the wiki. That was a little short on time.
We'll talk about the earlier tests. The first tests were conducted by Professor Thomas Leach at the University of Auckland, off the coast of Auckland and New Caledonia between 1944 and 1945. And if you're listening and you are on YouTube, you can pull up videos of nuclear bombs that they detonated in the ocean, and it's absolutely mind-boggling. So that's real easy to go find. So British and U.S. defense chiefs were eager to see this tsunami bomb developed, and it was considered potentially as important as the atomic bomb because it was expected to cause massive damage to coastal cities and we know that most people live on the coast. So very effective weapon.
Well, not to mention, the resources, let's say, of having a commercial port, on a coastline or something. You can inflict really serious economic damage that way.
Yeah, and when we get into the Russian version, which they actually have this bomb, their bomb is so big, it is 4 times larger than the largest nuclear detonation ever done on Earth, which is Tsar Bomba, which they lit off up in the Arctic. And it blew out windows in Scandinavia 900 kilometers away.
Wow.
And so this bomb, the Poseidon bomb that Russia has, the Tsunami bomb they have, is 200 kilotons, and Tsar Bomba was only 50. So it's 4 times bigger. Now, Tsar Bomba, when they did the test, sent a shock wave around the world 3 times, very similar to Hungatonga's explosion. So they're similar in size. This Poseidon bomb is 4 times larger, and it's a last resort weapon because no one knows what will happen if we detonate.
Yeah.
But, okay, so let's dive into our little experiment here. The weapon was only tested using small explosions and never on a full scale. There were 3,700 test explosions. That doesn't sound like a small scale, but I do digress. 3,700 explosions were conducted over a 7-month period, and the tests revealed that a single explosion would not produce a tsunami, but concluded that a line of 2 million kilograms of explosives at 8 kilometers off the coast could create a destructive wave. So details of the experiment's codenamed Project SEAL were released to the public in 1999, and guess what? Russia took that information and developed its own bomb in 2018. Let's get to the Russian bomb. Do they even have 2018, Russia released plans on a 20 to 100 megaton tsunami bomb named Status 6. But the current bomb they have is called Status 7, and it is a Poseidon torpedo. This torpedo is enormous, over 100 feet long, and it can sit on the bottom of the ocean in the off position and just wait to be turned on. When it is deployed, it moves just inches a minute, and it's undetectable by anything. So it could take weeks, months, or even longer to get to the destination once it's deployed by creeping along the ocean floor. And when
it's undetectable because of the slow speed? Is that what you're saying?
Yeah. It's just like a turtle.
Right.
And
or
plus
like
it's
a rock
very close,
moving along the ocean floor or something.
Right. You can't detect it. And when it gets within around 100 miles of its target, it accelerates at over 100 miles per hour in the water, which is you wouldn't be able to detect it until it's too late. So within a few seconds, it reaches its target and then explodes off the shore of the coastline it's targeting, and it creates a 500-meter radioactive wave. So if this were deployed, and I have let me pull this up.
While you're doing that, even just considering the creep of this bomb is really brilliant, right? When you think about it, because it's not like, I don't think that it's that it would be undetectable. It's rather that you would set your instruments to not pay attention to items that are moving that slowly, because there are going to be other natural items in the ocean that move that slowly along the ocean floor. So to eliminate that background noise, you would just say anything below this threshold we're not going to detect. And that's where this thing lies. And it's kind of brilliant that way.
Yes. So this comes from Russian documents, and this is the simulation that they used. The red dot is the detonation point off of Long Island in New York City. And you could see Long Island here is underwater. And this blue is the inundation from the 500-meter radioactive wave. It covers all of New Jersey.
That's a really crooked map.
Yeah, but someone stole it from Russia. So here you see New Haven, Connecticut inundated. Most of the coastal areas look at how far in it goes up here in Massachusetts. So this is an insane weapon, and hopefully will never be deployed.
Yeah.
Because you would kill tens of millions of people in an instant and then leave an entire radioactive coastline, that you couldn't really get near for decades.
Yeah. And literally tens of millions of people, like probably 60 million people or so. Yikes.
Yikes. All right. So interestingly enough, Tsunami Bomb is also a punk band who just broke up, unfortunately. So how do you like them apples? You disappeared from my screen. I hope you're still on there.
I'm here. You don't see me?
Okay, so Tsunami Bomb, bad idea, correct?
Yes, terrible idea.
Probably a great punk band, though.
Maybe.
All right, I just saw this article. It just popped up, came out today. Planting trees could actually speed up global warming. And scientists are warning, you better not plant any trees, buddy.
Yeah.
So here's go ahead.
Not in the wrong latitudes anyway, is what they're saying.
Yeah, they claim, I don't believe this to be correct, that if you plant trees up near the Arctic, that it will reduce the albedo and actually increase the temperature on Earth. So the only problem with that is if these trees are CO2 mitigators, wouldn't them eating the carbon dioxide actually be reducing the greenhouse effect? And so it might offset the albedo?
Right. Well, not to mention that they're likely to some degree to get covered in snow as well.
Right. And if you're up in the Arctic, snow tends to stay on pine trees. It doesn't melt off.
Right.
So each snowstorm, you would be back to normal albedo.
Mm-hmm.
Anyway, here's the paper. Tree planting is no climate solution at northern high latitudes. The whole problem with this premise is the fact that CO2 is a natural Earth respiration response. Does that make sense, what I just said?
Mm-hmm.
So the Earth breathes in a sense. And here you're looking at the atmospheric CO2 at Mauna Loa, which you can clearly see is increasing at a steady rate.
Mm-hmm.
There are no fluctuations in it. At no point in the last 30 years that we've had climate meetings like COP or any of those, have any of the climate agreements or the reduction in CO2 gases affected this graph in any way.
Mm-hmm.
There is no effect. So what would that lead you to believe?
That doesn't isn't that obvious that it doesn't matter?
It is so obvious. We need to say it though, because there are millions of people who don't understand that. Mm-hmm. This has nothing to do with you. This increase in CO2 has nothing to do with humans. The amount of CO2 in the atmosphere is 0.04%. Mm-hmm. And of that 0.04% of CO2, we contribute maybe 5%. That's it. It's such a negligible number. So that would be 0.002. That's what humans contribute.
This other paper that I think we're going to review, I was thinking, this one. I mean, one of the greatest fallacies in all of this is, we've been screaming and hollering for decades about the human contribution to CO2 and how that affects climate, blah, 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 without any understanding in the scientific field of the background of CO2, the part that has nothing to do with human beings. So how can you even draw any conclusions about the human contribution if you don't know what the background is? It doesn't make any sense. It's absurd.
Well, and on top of that, if this is the background and we are just contributing less than 5% to this, mm-hmm. then that's a negligible amount. It means nothing.
Yeah.
Because 95% is natural.
Yes. Yep.
So the best we can do is reduce carbon dioxide increasing by 5%. If we stop all of everything on Earth, we get a 5% reduction. Right. That doesn't do anything. A 5% reduction means CO2 will continue to rise 95% of the rate. Mm-hmm. So there's no way to bring this down.
Right.
There is no way to bring it down lower than it is. It will continue to go up until it goes down. That's it.
Yes. Yes. Let me throw something else out there too that's from this paper.
Yeah.
And I'm just going to read this little section because I think this is also a very good point. The author writes, common arguments trying to amplify the importance of human carbon emissions are that these accumulate in the atmosphere and that they cause temperatures to rise. The former argument is mistaken, as the atmosphere does not have any mechanism to separate the incoming CO2 according to its origin and to accumulate that part that comes from humans.
So in layman's terms, what I hear is that it doesn't matter if we make 5% more carbon dioxide, the amount that the Earth has, the upper limit is going to be the same, because we are in what's called a steady state. At any given time, the amount of carbon dioxide has to be exactly what it is based on the rest of the parameters on Earth. Mm-hmm. These tiny little parasites on the surface called humans that are lighting fires and farting, it doesn't matter how much we put in there, the total amount of CO2 will always be the same regardless of what we do.
Well, but the other thing that's being said here, let's say by the pro-anthropogenic global warmists, is this idea that somehow the CO2 that we as humans generate is somehow treated differently by our atmosphere. And that it's that part that accumulates and causes these changes in the climate, which is absurd.
Right. And in the abstract of this paper, the results show that the contribution of the former, that's CO2, is 4%, while water and clouds dominate the greenhouse effect with contributions of 87 to 95%.
Yep. It's worse than that.
Not taxing clouds.
Right. Right. It's worse than that in the sense that, and again, I'm just going to read from the paper. Human CO2 emissions represent 4% of the total, all of the carbon dioxide, which means that the total human contribution to the enhancement of the greenhouse effect is 0.16% to 0.2%. So if you're looking at the greenhouse effect in particular, that's the amount that our CO2 contributions adds on top of the natural greenhouse effect, which is largely a result of water. 87 to 95% water.
So what that means is that all these billions of dollars on climate goals, we need to get the temperature down 1.5 degrees. Even if we stop all CO2 production from humans on Earth, the effect will only be 1%, if any.
Yeah. Right.
There's no way to lower the temperature removing carbon dioxide. Carbon dioxide is not the climate control knob. Carbon dioxide is respirated by the ocean. As temperature rises on Earth, more carbon dioxide is released in the ocean, which is what this graph represents. This graph has 0% human activity in it. None of it.
Well, and one of the things, what they specifically show in this paper by analyzing the incoming and outgoing radiation is that this rise of CO2 from 300 to 420 has had a tremendously negligible effect on temperature. Because what they show basically is that the changes in radiation incoming and outgoing is what's doing the work.
So you're saying that the 1.5 degree rise since the Industrial Revolution has nothing to do with CO2?
Correct.
Wow.
What do you know?
Now, why don't you think that the mainstream media has picked up on this paper and it's all over the headlines?
That's another funny thing, because this paper, if you don't mind me reading again, sort of opens with a bit of a diatribe about the problem in science these days, and I think it's kind of brilliant. So they write, a notable feature of the current period is that the classical value of science as the pursuit of the truth, independently of other interests, is gradually being abandoned. People pride themselves on being scientists and activists at the same time, while calls for political actions to save the planet, including enhanced global governance, are published even in scientific journals. While common perception promotes the idea of science-based policies and politics, the reality is the exact opposite. That is, politics-based science. For it is self-evident that by mixing science and politics, the end product is politics. And then, it kind of goes on in this regard. And, they also point out that this affects publishing, and it in fact affected the publishing of this paper. And in the supplementary materials of this article is a link to all of the communication that they had with reviewers at other journals that wouldn't publish this paper, in order to show how political and non-scientific and non-truthful it is. I haven't had a chance to check that link out, but I'm sure it's very amusing.
Well, in that paragraph, it goes on to say a relevant example is provided by the high-profile journal Nature. This used to be the cornerstone of science, and it is absolutely a trash rag. Nature declares that it is committed to supporting the research enterprise, but admits being involved in politics. Same thing happened with magazines. When has ever magazines gone political? Because by choosing a political candidate, you eliminate 50% of the people on the planet from getting your magazine.
It's so inappropriate. It so does not belong there. Something else that they say here too, it is thus natural to wonder if articles published in scientific journals promote the truth or political aims, perhaps hiding or distorting the truth, and even reversing cause and effect. Gradually, by repetition and accumulation, distorted information becomes dominant among the scientific community and the public. And that's exactly what's happened, right? We've heard for decades now, global warming, anthropogenic global warming, CO2 causes temperature rise. And that's all that happens is you just keep repeating that statement again and again and again and again until people can't believe anything else. I was having a conversation with my father recently, and he was telling me that he's been having this dialogue with a nuclear physicist, I think probably connected through an ethical society that he likes attending lectures at. And, he's trying to show this scientist all of the arguments that essentially disprove the idea of anthropogenic global warming. And he's like, I just can't get through. And that's part of the problem, right? Like, it's like this dogmatic thing that is just stuck in people's heads. They've been brainwashed to believe it, and it has just completely taken over the science.
Well, this paper really approaches it in a new way, where if you're one of those brainwashed individuals, you can read this paper, and in the very beginning, it opens your eyes by pointing out that you may be brainwashed. So when reading this factual information, be warned that you're probably brainwashed and you will not accept it very well.
Well, I wonder how many other scientists pick up this paper, read the first few paragraphs, and then they're just like, I'm not reading anymore.
Yeah.
Because that's what happens these days, right? Whether it's science or some other observation of what's going on in our political system, people judge it by the person who's saying it or where they're coming from instead of actually looking at the data and the information. And they judge right off the bat, and then they will dismiss it immediately, let's say if it comes from somebody that they don't like. And it's just the saddest state of things, because it's not just science that this is affecting. It's affecting our evaluation of reality at every level.
Exactly. Maybe President Trump should hire us for the Department of Science Integrity.
How about the Department of Truth or something? That doesn't make any sense. But yeah, Department of Scientific Integrity. I like that.
And you can nominate us over at RFK's website, where they're allowing public nominations for anyone in the United States to fill a department there. So go get it.
I don't want a public office in any way, shape, or form. I do not want that to be my life.
Well, you definitely need to send this paper to your father so he can give it to that physicist.
Yeah. I mean, it sounds like it probably wouldn't make a damn bit of difference, but the guy should be able to understand the paper, so.
Yeah. Do you, anything else you want to talk about on this? I know you spent some time.
I spent some time. I didn't read it as thoroughly as I would have liked. I mean, no, I don't think I specifically have a detail. If it comes up, I'll mention it later.
And for those of you listening out in Radio Land, you can watch the video replay of this with all the graphics tonight, 8 p.m. on Magnetic Reversal News, where all the links to all of the papers will be below the video, and you can pull them up yourself. All right, let's move on to debunking Earth's catastrophe cycle. So earlier in the week, Ben Davidson shared this in his 3-minute daily update. He read the title. It has the word tilt in it, and he alluded to the fact that this article is evidence that supports his theory that the Earth tilts catastrophically. He didn't outright say it, but the way he presented it, 100%, that's exactly what he said.
I don't understand this, because does not one of his listeners actually go read the article? Because that's very tremendously easy to debunk if you just read this article, which takes like 3 minutes to read.
Yeah, and so this article is the paper. There is no paper. That's interesting enough.
Right.
So the title is Centennial Scale Jumps in CO2 Driven by Earth's Tilt. And so what they're doing year after year, there's younger and new scientists. They're re-examining these ice cores and drilling more and more. And with better techniques, they're able to get better and better data. That's why the ice core data keeps getting updated, because they keep researching it. And there's better ways to find gases that were in our atmosphere using different techniques. And that's what they did here. And they looked at ice cores between 190,000 years ago, all the way back to 260,000. So that is 70,000 years of ice. That's the core they took. And what it showed is that there were variations in carbon dioxide that were unexpected. And they go on to hypothesize what could be some of the causes of this. And they bring up the Milankovitch cycles, specifically obliquity, which is a 41,000 year cycle. And take a look at this. In 41,000 years, the Earth tilts between 22.1 degrees and 24.5 degrees. So
see, this is the part where I'm complaining about. Does no one read the damn article? Because that's all it's talking. As far as tilt is concerned, it is only talking about the change in the angle of obliquity, which is obviously very minimal. It has nothing to do with the idea of Earth tilting 90 degrees or something like that.
Right. And it's a 2-degree change over 20,500 years. So for 20,500 years, the Earth slowly gets more vertical by 2 degrees. And then for another 20,500 years, it returns to the position it was at 24.5.
Right.
And so what this does is it moves, let's say, the mid-latitudes. If you live in Colorado, in 20,000 years, it would be as if you were living closer to Wyoming, and then you return back down to Denver. That's it.
Right.
And it's a slow process.
And likewise, when they talk about jumps in CO2 that are associated with higher obliquity, what they're talking about is actually not very much. I mean, they fully acknowledge in this article that, for the last, whatever it is, 100 years or whatever, we gain like 1 to 3 parts per million a year. And then they say that what they consider a jump is 5 parts per million a year or more, which isn't really that different than 3 parts per million increase.
Right. So the normal respiration from the ocean is 1 to 3 parts per million per year right now. And we've gone from 315, which is some of the lowest levels ever in Earth's geologic history, to where we are today at 420. And their jumps add 2 more parts per million annually or more. Let's discuss this. What releases carbon dioxide? Animals farting, fires, volcanic eruptions. Any of these can explain a 2 part per million jump in a single year.
Well, and as well as decomposition of vegetation and stuff like that.
Yeah, there's so many things
all the time
we can blame on carbon dioxide.
Right.
The most obvious, in my opinion, and knowing the wildfire data that we have, prior to a lot of people being in the United States, which is heavily forested, we had fires larger than the size of states. That doesn't happen anymore. And people running around with their head cut off think the wildfires we have now are, Jewish space lasers and it's global warming and we're all going to burn up. If you were alive 300-400 years ago, entire countries could be on. Siberia was on fire for years at one point. And all of these types of massive wildfires will increase carbon dioxide by a few parts per million. So there are so many explanations. Certainly tilting the earth 90 degrees doesn't seem like a logical one.
I'm trying to remember what the explanation in here for why the change in obliquity increases carbon dioxide. I guess I already forgotten that. See if I can find it here.
Yeah, I believe they posited.
Okay, so here it is. I got it. Earth tilt controls how much sunlight falls on different parts of the planet. Obliquity changes the amount of solar energy that is shared between the poles and the equator. During periods of higher than normal obliquity, higher latitudes receive more solar energy. That change allows more vegetation to grow at higher latitudes and vegetation patterns at lower latitudes to shift.
They also allude that the shutdown of the AMOC could be part of it.
Yes.
So if you tilt, if you tilt correctly and you cool the ocean, or you get a Beaufort gyre release, you'll stop the AMOC, and that would then reduce carbon dioxide. It does the opposite in Europe, and then maybe later you'll get a spike in growth when you tilt back or when the AMOC turns back on. So all of these are hypothetical, but you could also add the things we talked about, obviously. Comet impact, a giant wildfire. Right. The Chelyabinsk event.
And all of those things, especially the amount of CO2 that the ocean respirates, it blows the human contribution to CO2 out the window completely. All of those things you just listed.
Yeah, because it's less than 5% anyway.
Yes.
Okay, from tilt to vegetation, do we need to talk about this anymore?
Well, between this and the other paper, I was also thinking this morning that, and maybe this is obvious, but I never fully put it together in my head. I was thinking about the fact that our monetary system is or was the petrodollar after it was gold based, and clearly the elites want to try to make our monetary system carbon based now, right? All of this nonsense about carbon taxes and all of this crap. And it's terrifying to think about, because if you do that, you're basing your monetary system on a completely made up scientific idea that has no basis in reality.
Yeah, but the eccentricity cycle here, this is the one that I think is the most important cycle that we don't understand. The reason I say is because you've seen the ice core temperature graphs, and there is a 103,000-year cycle that rapidly causes the Earth to warm, and we go into these interstadials. And then for the rest of the 100,000-year cycle, we're stuck in an ice age. So there must be some kind of, and I never believed in tipping points, but because of the change in the eccentricity of the orbit, there is something happening. Maybe it's electromagnetic that triggers this.
Yeah. Yeah.
Just don't know. The obliquity is the weakest of all of the Milankovitch signals, but
Yeah.
prior, the graph we've looked at, prior to 2 million years ago, it was the 41,000 year ice age cycle, not the 100,000 year.
Right. Right. I mean, because anytime that anybody's done any analysis on the effect of the Milankovitch cycle on the climate, usually what you come away with is that it's not enough to change the climate in the way we see empirically through proxy data, right? But that is based on, let's say, the effects of incoming solar radiation, how that's changed by the angle of obliquity and the eccentricity. So maybe the problem is that we're looking at it the wrong way. And as you suggested, if we looked at it from an electromagnetic perspective instead of just the amount of incoming and outgoing radiation, maybe that would help explain the change.
I agree. That's a very good point. And this is the most bizarre of the Milankovitch. And the fact that we think and still think that the Earth wobbles around every 26,000 years, which is the precession of the equinoxes, which we also call the Great Year. And that's because that blue line represents the tracing of the zodiac through the cycle. And it's such a small shift. The ancients knew about this because it's the only thing you could know by just looking at the stars for a long period of time. That's what they tell you. Here's the kicker. This is based on a Newtonian gravitational model. And more evidence is coming out that the Earth may not do this at all.
Right.
We are in a stationary rotational orbit with a single pole, and it's the planet itself, the entire solar system, that is spiraling through the Milky Way.
Right. Right. And you're not saying that, just to clarify for our listeners and viewers, you're not saying that the precession of the equinoxes is not happening, right? It is happening in the sense that that's what it looks like from our perspective. It's the question of what causes what we perceive to be a wobble, which is probably not really a wobble. It's probably more a function of how our solar system is moving and not some wobble in our axis.
Yeah, agreed. So we are in the infancy of cosmology. We don't understand even how solar systems are formed. The original ideas have all been pretty much debunked and nothing new has come out. We still are stuck with 100-year-old accretionary model of nonsense and the dirty snowballs.
I was about to
that
say
are comets. So when will this paradigm shift?
It's
as bad or worse than the climate science nonsense.
Yes.
Yeah.
It's the same thing in many respects. Not all of this, not everything of what we're experiencing now in science, but the slow acknowledgement of the evidence that we have that disproves the reigning theories. It's very typical of science. Thomas Kuhn wrote a very famous book called The Structure of Scientific Revolutions, where he talks about the shift, how scientific paradigms shift. And it is extremely slow. And I believe that it has a lot to do with something we've talked about on here many times, where you have scientists who have invested their entire lives and careers into a particular theory. So when a piece of evidence comes along that disrupts their theory, they just can't accept it because it turns their entire world upside down. And I think that plays a pretty big role.
Those poor babies.
I know.
Now
well, I'll give you a personal example. You and I, years ago, sat down and had a conversation with my father about electric universe theory. And it's interesting because my father is an electrical engineer. By training, that's what his career and his business was based on. And he just couldn't swallow that, despite the electrical engineering background, which I find
my
interesting.
father was a member of the IEEE for 3 decades. And I told him that the IEEE adopted the plasma cosmology model. He was unaware.
Yeah.
I don't know what he believes, but.
Right.
I mean, the IEEE itself uses the plasma cosmology model.
Yeah.
It's one of the only scientific institutions that are doing it.
Yeah. But when you've spent your entire life, believing a certain set of scientific theories, it can be really hard to shift that for some people. And I think it's personality dependent, right? Some people are more quick to drop dogmatic thinking than others.
I can agree with that. Yeah, I think it's a personality type.
Mm-hmm.
Now, we've talked about this paper in the past. Do you remember when we did that on a show?
I think so. Yeah, vaguely. Now that you mention it.
Because we went over dipole, quadrupole, and octopole.
Yes, I remember that.
So this is a Russian paper from the Russian Academy of Sciences in Moscow, and it goes over field strength data. It uses machine learning and, Fourier analysis type models to look at the dipole data that we have. It's using multipole expansion in the mathematics. And this is a mathematical series representing a function that depends on angles, because we're talking about a sphere, the Earth, and its poles moving around. You need to use multipole expansion to get a clearer and crisper picture of the dynamics of what's happening.
Mm-hmm.
That's a mouthful.
Mm-hmm.
Multipole expansions are frequently used in the study of electromagnetic and gravitational fields, where the fields are distant points, and we're talking about a globe. So here's a great picture of some of those multipoles. So in the abstract, and I find this fascinating, it can be assumed that reversals and large-scale variations of the geomagnetic field between reversals have a lot in common, and that the wavelet analysis carried out, meaning the mathematical study they did, and this is using all the field strength data that we have probably. They went out and collected as much field strength data from all different sources to do this model. It's similar to what they do with climate models.
Mm-hmm.
But what they found is that the main geodynamo cycle is arbitrary. Let me repeat that. The main geodynamo cycle is arbitrary. The period of oscillation can vary from 8 to 10,000 years all the way up to 20 to 30,000 years.
Mm-hmm.
That means there can be a 30,000-year gap when there's no geomagnetic field variations in the form of magnetic excursions or reversals.
Mm-hmm.
And there are people, tens of thousands of people, that think that there's some 12,000-year cycle that's going on, and it's predictable, and it predicted the flood of Noah and blah, blah, blah. But it seems to be far from the truth.
Mm-hmm.
And here's that analysis. This is the evolution of the asymmetric dipole here, the quadrupole here, and the octopole here. And based on the math, the octopole and this is normal field strength above match like 100%. And this allows them to search for some type of pattern in the field strength, and there is none.
Mm-hmm.
I want to say the word fractal, but that's geometric. It's just random.
Right, right.
But is it?
Well, it might not be. It might be that the pattern is so large that we just can't see it, and we don't understand all of the things that are contributing, right? Because the other thing that this paper tells us is that it's like when all of the minimum amplitudes of these different poles line up is when we're heading into a reversal, or I want to say an excursion.
Yeah.
And so to me that suggests, so what you're dealing with is you're dealing with several wave patterns on top of each other, and you're waiting for them to line up in order to predict a reversal or an excursion. And the problem I think that we have is that we don't see all of the things in our solar system that may be contributing to those amplitude changes. And so, and the pattern may be so long in time that we just can't get perspective on it.
Yeah, I agree. What's also interesting is when you're looking at some of these excursions, like the Lechamp here, it doesn't seem to be much different than any of the other excursions, yet it was.
Right.
And then I forget what this one is called, but look at the distance between these two excursions is over 20,000. Not a 12,000 year step there. There really is very little periodicity to the field strength. This is from a different paper, and it has a little higher resolution data. And you can see in the last 12,000 years, if you want to get down to brass tacks, we've had 1, 2, 3, 4, 5 magnetic excursions in 12,000 years.
Yeah.
And then here we have the next 20,000 years. There's 1 excursion, 2, maybe 3 down in the Mono Lake, 4. I mean, there is no pattern.
Right.
And the high variability from the Lechamp all the way to the peak field strength, that is a 24,000 year time period of rise.
Yeah.
So what is the cycle? Is it this long-term cycle that we're going to call an excursion? Do we call each of these blips an excursion? Because it's arbitrary. They call this an excursion, and this one. Why not here and here? Why not here where it dips down lower than the Younger Dryas event? That makes no sense.
Well, so I mean, I think we do need a better definition for excursion, right? Because one of the things we've talked about before is that sometimes an excursion is a situation where the magnetic poles flip, but only for a brief period. So we don't call it a reversal because it's not lasting. But in fact, are all excursions like that? Because it would be better if we had that differentiation.
Right. And the Lechamp, the field reversed multiple times. We had multiple poles, maybe for 100 or 1,000 years, and then it went back to normal.
Right.
So there were reversals going on for a period of time, complete reversals.
Right.
But because it went back to the way it was, they don't call it a reversal.
Right.
It's actually been almost 800,000 years since the last one, right? 780,000 years ago, the North Pole was at the South Pole. That's bizarre.
Magnetically, not physically.
Yeah, not physically.
Just to be clear.
And so this is the question. Because there's no cycle, because it's highly variable and random, and we have these really deep spots, and we do know something about cosmology. We do know Barnard's star was much closer to us 40,000 years ago. Is it the magnetic effect of that star being close that does this? The fact that we're not studying electric universe, we're not giving electromagnetism a chance, like who at university level is looking into this from a fresh perspective of a non-Newtonian view?
Well, we're also, even from a Newtonian view, we're not considering sort of from a Newtonian view, we're not considering the role of, let's say, other solar systems nearby, right? Because all of these things are moving quite a lot in relationship to each other. You know, things aren't just static in relation to each other in the universe. So, and what is the role electromagnetically of that? We have no idea.
Well, and the elephant in the room is our own sun.
Right.
Which we now know, and all solar scientists know, that our sun is a highly variable star. Yet all the climate models use a solar constant.
Right.
That is, first of all, man, science is broken.
Well, and you have to, when you say a highly variable star, like you have to consider that as well. Like what are the electromagnetic patterns on the sun? Like, is that a pattern? Is it random? If it's either one, why? Like, what causes that? Is it because of its interactions, let's say, with other stars through Birkeland currents or whatever? I mean, like you said, science is broken, and there's a significant lack of acknowledgement of what we don't know and what might be playing a role in all of these empirical observations that we make.
Right. And in fact, if the sun does influence Earth's magnetic field, which we know is true in the sense that when the sun is highly active and shooting solar flares at us, the Earth responds by swelling the magnetosphere to protect the planet.
Right.
And when the Earth or the sun goes quiet for extended periods of time, the magnetosphere shrinks.
Yeah.
But what is the additional control that the sun has on our magnetic field? We don't know. It may be that this entire graph, the field strength of Earth, may be directly controlled by the variability of our star.
Right.
Why aren't we studying that?
Well, because we're stuck in, the model that even this paper is using, right? That the magnetic field of Earth is controlled entirely by the Earth's inner dynamo and the liquid inner core, blah, 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 which we don't even know if that is true. We don't know what is in the inside of Earth, but yet we have all of these theories we have all of these explanations based on a theory that is unproven.
Yeah, so what we would have to say, using the old nomenclature, is that this field strength varies based on the speed that the inner and outer core are spinning. Because
right.
It slows down and the field strength dies off. It's kind of cockamamie in the sense that magnetic fields are residual. The former place that the magnetic field hovered above Canada for 100+ years, now the magnetic field is moving. It's now over the Arctic, headed towards Siberia. The place where it was sitting for hundreds of years is still magnetized, as if it's still there.
Mm-hmm.
It's called remnant magnetism, and it takes a while to wear off. So what that you could glean is that maybe the magnetism of Earth is a remnant from some other source that's creating it externally.
Right, yes.
And bringing it here. And the way it brings it is through the poles in both directions that meet at the core, and it's creating a magnetic field there. You don't need liquid inner and outer iron things spinning.
Right. Well,
all you need is something metallic and electricity.
Right. But
and that's coming from the sun in the form of a Birkeland current all the time.
Yeah. I mean, I also find it's the same reason that I said this about the sun. I find the idea that Earth's magnetic field is totally controlled by what's going on internally kind of stupid because specifically because of this incredible variability and lack of pattern, which would suggest it's being affected by something. It's the same reason why we would ask that question about the variability of the sun. Like, what's causing that, right?
Yeah, and in order to get to zero field strength or a reversal in a magnetic field, what happens in the core to do that? Does the core reverse its spin?
Right. Well, it's funny when you think about it because this is very Newtonian thinking what we're saying right now, in the sense that, the basic premise essentially of Newtonian mechanics is that things will continue as they are until something happens to change it, right? If you have an object in space moving, with a certain momentum, that doesn't change unless something else happens to affect its movement, whether that be friction or a collision with another object or whatever. And so it's the same thing here. Like, why do we have this tremendously variable sun? Why do we have this tremendously variable magnetic field strength on Earth if it's not being affected by something other than itself?
Yeah, that makes no sense.
Yeah.
We've got a long way to go. Hopefully, what we revealed to you today is that we don't know nothing. But what we do know about that little bit of information is that we are in a magnetic excursion currently. It could rapidly drop to the bottom in just a period of decades before it returns. And we don't know why. But what we do know is that the last few solar cycles are getting weaker and weaker than solar max, which was about 3 decades ago. We do know that the field strength of our planet is also weakening, and no one knows why, but it happens all the time. Take a look at the graph. Sometimes it gets strong and sometimes it gets weak. And in times of weak field strength, we've got a shrunken magnetosphere. What we know and what we've witnessed is aurora to the equator with small geomagnetic storms. And it's only going to get worse and more interesting as time progresses.
Yeah. Most definitely. It's funny as well that we have lots of people thinking very conspiratorially about the appearance of aurora at low latitude, like the assumption is that it has to be human induced, because I haven't seen this in my lifetime. But if we look at the longer scale, like clearly the power, this happens all the time, and the power to do that has nothing to do with us.
It's HAARP.
It is not HAARP. Find us tonight on Magnetic Reversal News at 8 p.m. Mountain Time.
It's boom.
Listen to Revolution Radio at freedomslips.com. And we'll be right back after this message.